So everyone, I am talking about clean architecture with Django. Just a little bit about me. I'm a CTO at a company in London. It's an ad tech company. We use Django a lot. And I've used Django since the late 2000s. For at least, I would say 14 years I've used Django. So I know a little bit about it. I've done a lot of projects. And I've had to grapple with architectural issues a lot. It hasn't always been that easy, especially when you're in an environment where your requirements are changing a lot. And I think that clean architecture is geared to deal with that kind of situation. So clean architecture is a book and a set of ideas by Bob Martin. I think the book was published a few years ago, but it really represents a collection of ideas that have been around for a long time. In the description for this talk, I mentioned hexagonal architecture and onion architecture. I'm not really going to discuss those explicitly. I do have links to those in the references at the end. The reason I won't go into those specifically is because of time. But I'm going to treat these all as the same kind of architectural argument about how systems should be designed. Now, just to establish a frame of reference, we're talking about typical Django applications, which are web applications, and they have a relational database. A lot of people reasonably try to use other backends like MongoDB or other kinds of storage backends, but we're going to assume a pretty standard approach to Django, using a database, some transactional logic, and views, Django views, regardless of whether you're using templates or a JavaScript front end. Django has a lot of other stuff, and these are reasons to use Django, like the admin interface, user authentication framework, migrations, and all that stuff. But people, the typical way of using Django is to select it because of this ability to build your data models and expose those through views very quickly. Clean architecture is intended to reduce the cost of change, make things easier and faster, get independence of your solution components, better testability, and reduce costs. Now, that sounds like a list of all the good things that you always want, but there is something here that's rather important about clean architecture, which is it is about managing change over time. And there's a very important part of this, which is that it's mostly after an initial investment in design. I think that the primary idea that one needs to get hold of is this idea of the arrow of dependency. And I'll just quote here from Bob Martin: high-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. Clean architecture is for making it easier to change things. So this is very schematic view of this central idea, which is that you have volatile parts of your code base and they depend on more stable parts of your code base. So looking at it in the context of patterns in general, this dependency rule, which I have at the top here, it's a very general rule that really governs everything else and is a more general thing than some of the others. The things at the bottom, like model view controller or model view template, it's not that they're irrelevant, they're just less important for this perspective than these higher level concepts. This is a kind of ubiquitous diagram that you'll find on the web everywhere. I am going to show it to you, even though I'm not going to return to it exactly in this form, but just so you have it for reference. In the middle is this more stable part of your code base. Going towards the outside, you have less stable parts of the code base. And you want these arrows, as shown on the left there, to be pointing towards this inner part. So the inner part of these, your domain model, surrounded by your use cases, surrounded by controllers, gateways, presenters, and then all the more incidental detail stuff, devices, web, DB, UI, external interfaces on the outside. So going back to this more schematic view, but with more detail, we have databases, we have views, we have integrations, and we want these this dependency to be pointing inwards. So very important for understanding this in terms of Django. The UI mechanics are a detail, which is why the views, and I do mean Django views or Django REST Framework, the same thing would go for that, is on the outer circle here, meaning it's the more volatile part, the more detailed part of your code base. Now, it's really important that if you research clean architecture or you buy the book, you'll notice that he doesn't really mention Python more than maybe once or twice in the entire book. It's very geared towards Java and C++, but that doesn't matter too much, I think. I think if you come from those, the direction of Java, you're probably going to, the first thing you're going to say is, where are the interface constructs in the language of Java? As we all know, Java doesn't have that kind of construct. So there is a very big bias here, and he would tend to see design happening up front involving a lot of interface design, and we're not going to have that in Python. Another thing that he says very clearly, even though this quote is taken from a different source than the Clean Architecture book, it's something that he does refer to very frequently. Architectures are not about frameworks, and they should not be supplied by frameworks. So your Django framework design is not your application design, and that's a very important point that is essential to clean architectures. So interfaces are abstractions, and most dependencies should be on interfaces, on abstractions. We don't have in Python a interface concept or language construct. But we have other things. We have abstract classes. It's not the same thing, but it can serve as somewhat the same thing. We also have duck typing, which might surprise some people that I mentioned that here. But that is one way of implementing abstractions, which is to agree on conventions for interfaces, where you say that objects should, by convention, implement a certain set of methods, get, put, for instance, and this abstraction will work just by using duck typing. The other way is factories, which I'm going to talk quite a lot about, and dependency injection libraries, which I'll also refer to. So we're going to need some other substitute for the missing interface construct in Python. Now, best use case for Django, this is my opinion, is you have basically the schema, but the essential factor is that your models, the way they are put together, they will represent a domain that is very similar to the way you want to present that domain through your views. And I'll come back to this again later. It does get a bit tricky when you have a complex business rules situation where you need to do a lot of things in between modeling the your domain and your presenting that through the views. So dependency inversion is a key factor that runs throughout clean architecture. And it's just a way of changing this arrow of dependency if it's pointing in the wrong direction, like if it starts to point outwards from that more stable parts of your code base, you don't want that, and you can use dependency inversion to change that. And one way of doing that is using dependency injection. It's a little bit confusing because you see the abbreviation DI everywhere. There are two things here going on. Dependency inversion is the concept, and dependency injection is a pattern that you can implement to achieve dependency inversion. I believe the first mention of the injection pattern is Martin Fowler. There's also a Python dependency injector framework that I reference here. I'll also mention in the references. I'm not going to use that here because it's a little bit complicated, and I think in many cases you don't need it, but you might want to have a look at that. Now, one of the things about, I'll just mention here, even though I told you I wasn't going to go into these other hexagonal and onion architecture things, there's a way of expressing this going from one layer of abstraction to another in clean architecture. He uses the phrase interface adapters. In the others, it's sometimes ports and adapters. Just so you know, those are synonymous. So we want to use interface adapters to just keep the dependencies pointing in the direction of less volatile, less detail-oriented code. Now, I really consider the Django ORM to be a pretty critical part of the Django framework. It would be hard for me to imagine using Django without using the ORM. It gives you great create, write, update capability, and it's kind of simple in the way it works. It's easy to understand how to do it. You define your data model or domain, however you want to look at that, and you can get going very quickly. And migrations are in general pretty easy to use and save you huge amounts of work. So this setup, in my view, works really well. Now, it's important with respect to clean architecture to appreciate what the ORM is doing. It's doing a lot of stuff. You're modeling your domain. It's doing database connection management for you. It's doing the object state management for you. It's doing caching. This is a bit of a problem for clean architecture because those are all detail things, except for the data model, domain modeling. I should have put probably data modeling there. You're mixing up things that are supposed to be separate. The domain modeling belongs to the inner circle or the inner two circles, whereas everything else is the outer layer, and you're mixing those up already. So you've already got a situation that's, according to the dependency rule, is somewhat mixed. And so the ORM has a lot of responsibilities. This schema and data migration, as I said, state management, all that those are details. And I'm going to give you an example of what I mean by, in particular with regard to data modeling versus domain modeling. So let's assume in my industry, we have this concept of an asset that can be a print asset, or it can be a digital asset. And I can model that on the left by, as you see, defining a Django model that uses inheritance. Now, I could also do the exact same thing by doing the set of models on the right, which is not using inheritance of the asset model. I would just have three models, whereas I'll have, three tables, whereas on the left, I'll have two tables. And the point here is I'm making decisions about the data schema, and that is absolutely a detailed decision that really shouldn't have anything to do with the domain. This is really important. So there are also additional limitations to the ORM, and this would go for most ORMs, not just Django's. one of the things that's it's a little bit difficult maybe to explain without a lot of examples. Your model representation is a snapshot of your domain that's valid for some ways of using or supporting a set of use cases, but not necessarily all of them. I also, it's my opinion that I think that the query set API is fantastic. I love it. You can do a lot of things with it. In fact, you can do almost everything with it. It's amazingly powerful. And it's also extremely well designed for performance. But that API does get to be a little bit awkward in introducing quite a lot of things like outer refs, F functions, in order to push functionality down into the database. It gets a bit complicated, and that kind of waters down the argument of simplicity on a simple interface a little bit for me. The other thing is it's not very good at doing certain things like vectorized operations. So if you're using NumPy, for instance, you want to be able to operate over large in-memory objects. In order to do that with the ORM, you need to convert everything to some kind of Python type, and then you can do that. And it doesn't support it directly, and you might, for some, not all applications, you might need to do this a lot. The same thing with geospatial operations. I find, like I said, that the query set API is amazingly good, but I find it kind of gets more difficult when you get into more specialist areas like geospatial operations. There's GeoDjango. It works very well, but it often doesn't work well enough to cover all the use cases. The other thing is CQRS. So command query response segregation, pretty awful acronym, usually involves two things, and you can just do the one if you want. Reading from a different source than writing. So if you, for instance, use the ORM to do all your transactional work, you could use a different data source that has the same data that's optimized for reading. And this brings you outside the object relational mapping in Django. And you have to think of all these things and what your use case is. So I'd like to introduce a concept. This is my naming, and it's just to express the idea that you can have objects that are context-free, meaning they have no dependencies other than the Python standard library. So they wouldn't have integration state. They have no framework dependency, so they can't be from a framework other than the Python standard library, and they have to be very easy to create. And I'm going to use this concept later. That's why I'm introducing it now. So we could do this. If it's a problem that the ORM has these shortcomings in the sense of mixing details with the domain, we could say, okay, fine, let's just create an interface adapter on the entities layer and have that call the ORM, and we won't see the ORM from our views, and it will just return dictionaries, tuples, or data classes. And we could do that. The only problem with that is it does undermine the Django framework. So you're not really using Django in the way it's meant to be used. And I want to come back to this thing that I've said before. This is, for me, the Django ORM use case principle. If the data representation in the view is similar to the model layer, then you are well within the principal Django use case. And that's going to work well for you. You'll get great performance. It'll be easy. It'll be a good experience. And here's now a schematic representation of that in relation to the normal schematic view of clean architecture. I have up here, that's a view function. You can see the request parameter, and it's going to go get the average price of all my books, and it's going to return that. But you can see that this is not very clean architecture because the arrow is not pointing inwards. It's pointing to another detail artifact. Now I can change this to do something like this, where I have a price engine, let's call it. This is a very simple example, but you can imagine more complicated pricing algorithms. My price engine has a method, get average price. In my view function, I create an instance of the price engine, get the average price. You can see in the view function, I'm not directly interacting with the ORM. Now, here's a more complicated view, but it's the view that expresses a way to start implementing the clean architecture dependency rule. So instead of the previous one, I'll just say, first of all, this does the same thing. It does the exact same thing, but it adds one piece of functionality, which is that it will select a different price engine depending on whether it's the summer or not, whether it's June, July, or August. It'll return a pricing engine that does discounting. So what I'm doing here is I've got a factory function that will be in a different module, by the way, and it's going to get me a pricing engine. And I have an interface, an abstract interface that will define what that pricing engine looks like. So that's my abstraction. And in the view function is the very end. I get the factory, or I get the pricing engine from the factory, which automatically selects whether it's a discounting price engine or not. And then I get the average price. And as you can see on the right, I'm really implementing this sense of abstraction using dependency injection, which you can see in the factory. I'm creating this object through an abstract interface. And this is kind of the main thing. And again, I note that the ORM, even though you could say that the part of it is in, should be the domain definition, which is in the entities, because of it's mixed up with details. It's really part of the detail layer. So here's another example. I want to call a reservation. Let's say it's a hotel reservation service. It's a API service. And I've got start end dates. I've got an object in my ORM that's called a reservation. It has the start end dates. Now I'm coming up to those dates, and I want to check to see if the reservation, what the state of the reservation is, that is whether the room is free or not. So the only problem with this is if I pass that ORM object to that API, so I've written my API client, and that is using the start end dates of the reservation object, I'm going to end up with this. And this is a problem because we end up with what you see here on the right, which is kind of a spaghetti code effect where everything is related to everything else. In this particular example, it seems simple, but it will very soon become quite complicated and difficult to maintain. So a better solution would be to, again, use a service factory, which is going to create our reservation service for us and inject the client for calling the external API. And then I can also use this make context-free reservation. And you'll remember I explained that for me, context-free means that it's an object that doesn't have an integration state. It's very easy to create and manipulate. And it's mostly or entirely a Python standard library object, like a data class in this instance. And then I pass that to the integration, my integration client. And you can see there that the result of doing that prevents this cross-detail dependency. And that is going to be pretty helpful. So, we want to try to do that kind of thing. The only problem with it is it's going to cause us to use the ORM in a way that, as I said before, is not part of the standard use case for Django, which is in views calling the ORM, which is the easiest and most frictionless way to use it. Now, I've written a project called JAQ. It stands for Django Query. It uses it provides a query language based on strings to query the ORM for objects, and only returns Python standard library objects like dictionaries or tuples or lists. Now, the reason I mention this here is just to show that you can break up the ORM into its different features. But I will remind you that I showed you on a previous slide that this has the limitation that you're dropping the standard way of using the Django views and ORM. But you could do this kind of thing, okay? Or you could use some other mechanism to do that. There are resources out there that would tell you how to do that. REST frameworks for Django, the only thing I want to say here right now, just because we have limited time, is that they are very much involved with the ORM. So it's very difficult to once you're committed to them, they are going to refer to the ORM, and it'll be very unnatural to try to pick that apart if you're using Django REST framework, for instance. So I have a few recommendations, and I make these recommendations based on personal experience. There are a lot of things that you can do in order to implement clean architecture principles. First thing is obviously just to be aware of what those principles are, and to appreciate the fact that if you try to do things like this, you're going to incur overhead that you don't have if you use the standard Django use case where you're calling the ORM from views. So just remember there's going to be a cost to that. So do try to minimize dependence on details, however. So if there's any code that's not part of your business logic code or from the Python standard library, you want to avoid passing those objects or variables through the call tree. And this is going to enhance your experience very considerably, in my experience. So avoid passing context-dependent variables as far as possible. Try to avoid this cross-detail dependency, except for the ORM Django view dependency, which is just part of the Django framework, and it's kind of the reason for using Django. So it doesn't make a lot of sense to try to get rid of that. Don't rely on integrations any more than you have to, and you need to isolate those. And just try to use the Python standard library whenever you can. And remember that Django is a framework. So Django is for doing web things, for serving data models that look from the outside like the domain you've modeled. Try not to, another example of a context-dependent variable is the request object. And this is something that I've seen time and again. If you pass that as a function and it keeps getting passed through the call tree, you're going to be stitching your whole architecture together with this detail thing. And you want to try to avoid doing that. It is an integration object. Use Django the way it was intended. Use dependency injection as much as you can, actually. Again, I don't personally use a dependency injection library, but it's very simple to use if you use the factory pattern. And there's a great way to test whether or not you're doing this. And I call it the REPL test. So REPL is going to be IPython, Jupyter Notebook. There's a default Python REPL, of course. And there's the debugger. I mean, I use IDB a lot, but it can be any debugger. The point is that your code should easily load into these things, and you should be able to import a module and create constructs of those modules without going to a lot of trouble. And that is a heuristic test of whether or not you're producing context-free code. And the same thing goes, you really want to be able to create Django management commands for testing functionality or doing various tasks. And it's very frustrating when you can't do that because all of the interesting features are bound up in views and you're trying to call them from the command line. Unit testing is going to be massively easier if you apply these principles. Mocking is just not going to be as good as when you're using context-free objects. It's just much easier to test. And try to understand how your project's going to change. It can change in one of two ways very generally. One is you can just add more apps that do more of the same thing, or there might be a growth in functional diversity, and that will be much more complex kind of change. Really important here is Django is, and I hope this isn't too controversial, Django is for making it easier to get going very fast. And that's the opposite of clean architecture. Clean architecture is, the expectation is a lot of initial investment and then everything gets easier afterwards. Now, I think you can combine these two things. That's something that you need to evaluate for yourselves. Here's a few references to get you going with research. And I want to thank everybody for listening. I got a lot of help from some colleagues and friends. So thank you very much. Okay. I was on mute by default. Is anybody up to hear me?
Yep, we can hear you.
Awesome. So I'm not sure what the protocol here is, but if somebody wants to go ahead and pose any questions.
Well, I have a question.
Sure.
So can you go in more detail about why a model instance cannot be considered as an entity and is considered as a detail?
Sure, I can. Because models are they are a domain. They can be a domain instance or a domain entity that you're designing, but they're also that code also does a lot of other things. I showed you this one example of having a polymorphism for an asset instance that can be print or digital. And there are different ways of defining that depending on what data schema you want to end up with. And you're making those decisions while you're designing your model. And this is completely contrary to the idea of clean architecture. The idea of clean architecture is that you design your domain in complete ignorance of the details of how it's implemented. So that's very not clean architecture. That inner circle with entities should be purely a description of your domain. It is code, by the way, that we're talking about. It is your code base, because we're talking about dependencies of the outer layers on the inner layers of code. There's no question about that. But the assertion that Bob Martin makes is that you are defining code that represents only your domain, and then how it gets populated, whether it's cached, all these other, how it is represented in a relational database are totally separate concerns that you shouldn't be concerned about while you're writing that code.
But isn't that, depending on how you write your model, isn't that what you actually do in a model? You describe an entity and you say this entity has this and this and that property. And that's your code. So your code, that piece of code is just describing that, isn't it?
Well, his assertion is that that's not the case, because what you're saying is if you have a bookshop and you have your model book, it has a title, it has multiple authors. So one of the things about that is a great example. First of all, if you say it has a title, you're saying there is one database field. If you say car field and then max length, you are saying something about the technical implementation in a relational database, which is there's going to be one field for that in a relational database. If you say I have now a M2M field that is the list of authors that can be anywhere from 1 to any number, you're saying that you want a no field, but you do want an additional table with 2 fields in it, an author foreign key and a book foreign key. So you're making those detailed decisions when you say I have an authors field and it's a M2M field. So that's not really domain definition or domain description. It is that as well. You're saying that books have authors, but you're also specifying how that's to be laid out in the database.
Okay, thank you.
Sure.
So 2 things. I wanted to make a comment on that. Like there's a good example of like what your models isn't your domain necessarily. For example, you can use the same model in different contexts. So your user is a different user for your accounting domain than it is for your like delivery domain or for your whatever configuration user settings domain. So the information you want from that user is different in those different contexts. They are all represented by the same database table, but the information you want to extract from that is completely different. So if you treat your model as your domain entity, you end up with a lot of properties in your like model class, trying to represent that same database table for all of those contexts. And if you have different objects as entities in all of those contexts, you can like separate those concerns, and doesn't matter if they belong to the same database table. So you get different information in which one of those concepts. I think that's a good example of like why they're not the same thing. But what I wanted to ask is, like, do you have any examples of like practical implementations or kind of a framework of how to link the common Django objects to like that schema, for example, because I find it really hard to push to like usual Django developers that kind of way of programming. Normally people find it very difficult to understand that and very bureaucratic to introduce those layers between the common Django stuff we use. So I was wondering if you know any kind of like facilitator to introduce that.
Unfortunately, I've had this same experience as you, which is I find it very difficult to to do this, and the natural. I think part of the problem is that Django works really well if you don't do that. In other words, if you just directly use the models and in views, you're using like you look at the book. I think the Django documentation has a bookshop example, and it's just so seductive because it's so easy to use it that way. And then, of course, as you're pointing out, then when you want to say, okay, things are getting a little bit more complicated here, and it would be better if we separated out the layers and recognized that business rules are now being implemented in views, and we don't really want them there. And then you have to start separating them. And I honestly, I don't have I mean, I do have kind of a methodology for that, but I don't think it's very magical, and it's not recipe-like, here's a list of things to do. But using factories, I think, is massively useful for decoupling. Also making sure, for instance, you would have factories in a different module. You wouldn't have them in the same file because you want to reduce dependencies. You don't want the dependency to be on the same module or on a different view module that happens to have a factory that you want to get a hold of. So there's no magical way to do it. I do have a description of way to structure this stuff in a online read the docs article called it's on my GitHub page, and it will describe as an example a way to structure your directories, and there will be more discussion of applying the solid principles. I try not to go into too many architecture issues there, but it does talk about ways to do that. But I'm not claiming to provide a recipe to fix that.
Thanks.
Python coding guidelines at .read the docs is the thing.
Maybe I can share a little experience that I have made here. As long as I was having the good situation that I could just pass through model attributes to the view component, it was pretty straightforward to use the Django mechanism. As soon as I needed to calculate stuff based on different parameters, I ended up in pulling this out into an own entity or logic component to do this number crunching, so that I can reuse this in other places and also change the logic quite easily and stay dry in this context. So this might be a quite easy or a quite straightforward scenario where you can think of implementing this clean architecture principle. And we also have services that do a lot of business logic, and we moved them into their own component and via factory pattern made them usable in the different places in our code base.
Sure. Yeah. You're describing exactly what I've experienced, So in my company, we have to do quite a lot of calling out to external services that enrich data in the models, and then we have to do operations that require knowing everything about everything in the entire database of like an asset. Because you have to do things like give me the top assets that have some data attribute, and that data attribute came from a foreign source. And this is not really that easy. You can't really do it effectively within the ORM. So you end up extracting everything from the ORM and then doing everything you need to do. And then you need to separate out things that need transactions and things that are read-only. So you've kind of described exactly the kind of things that I've experienced. Anyone else?
I recently had an experience of trying to, we couldn't really change much of the architecture because big code base with not much time. But we started cleaning some surfaces of it, maybe. So we kind of started introducing some objects, for example, value objects, where when we need, for example, to implement some business logic that involves different entities, different models. So we try to create this value object that does all these magical things, and we pass that value object to views. Then extract some things into services, so things that depend on external things, they become services. And one useful thing was to introduce use cases that have this orchestrating role. But one thing I wanted to do was to gather all people that like this kind of thing and try to build a more consistent architecture to have a guide to say I have this big legacy code base. How do I start to clean that up with those concepts? I have the impression that everyone does a little bit. There's not a great solution where you just jump right into that and start.
You're describing something that's very universal. You said at the beginning that you had a big job but with little time. Django is fantastic for that situation. It really is. It's just that as things evolve, it gets messy, and then you have to start organizing things, as you just said. And I think that you can continue. It's not like you have to get rid of Django and then use something else. I don't think that's the case. I mean, what I'm doing with my colleagues is we're using Django for the things that it's really good at, and then using other parts of the architecture, we're using other things. Like we use a CQRS kind of architecture. But for straightforward objects where, like I said, the objects, the way they're modeled, look like the views that we want to present, then it's no problem. For other things, that won't work. But you can use both. And the things that Django does well, it does really well. Okay, we're getting down to a few people. Anybody else? Okay, maybe we're done. If no one else has anything, I'm very grateful for the comments, by the way. Thank you so much, and thanks for listening to that.
Thank you. It was very interesting.
Thank you. Okay, I'll see everybody.